Hi, welcome to the series Maths is Easy, Maths is Fun. In this video, we'll continue our discussion about three-dimensional figures or mensuration studies. Now, let's look at a slightly complex example. Let's take an ice cream vendor. We have an ice cream vendor who keeps his ice cream in a right circular cylinder with radius of base 30 centimeters and height 1 meter. He serves this ice cream in yummy waffles, right circular cones, and the serving that he offers his customers is to fill in the entire conical portion inside and then give a hemispherical scoop on top. If the vertical length of the ice cream cone is 10 centimeters and the radius of the circular part is 3.5 centimeters, how many complete ice cream servings can he offer? Let's analyze this step by step. Okay, part 1, right circular cylinder. Total volume is, let's say I denote the radius as capital R. In this case it is 30 centimeters and I give the height as capital H, which is 1 meter. I am using capitals over here so that I distinctly know this is the large structure that I am talking about. Now we have a smaller structure. Ignoring the thickness of the waffle, I have a conical part. Let me say the radius is R. Observe one thing. You've seen an ice cream, how it is. You have this cone over here, you have the base, and then you have the hemispherical portion on top. So radius of the hemisphere and radius of the cone is going to be the same. We know the height of the cone. Let's say this is small h. We know the radius in either case is small r, 3.5 centimeters, that has been given. So what is the total volume of ice cream? It is going to be 1 upon 3 pi small r square h. What is going to be the volume of the hemisphere? It is going to be 2 upon 3 pi r cube. And what is going to be the total volume? If the total number of ice cream servings are n, you are going to have n into a large bracket 1 upon 3 pi r square h, all small, plus 2 upon 3 pi r cube. This entire thing put together is equal to the large pi r square h. Do you see pi cancels out on all sides? You will have a lot of common factors that you can cancel out. So whenever you have problems related to mensuration where they say, okay, you have a block of metal and it is drawn into a wire, or you have a large right circular cylinder and it is melted into a pyramid, so on and so forth, the first thing you need to do is set up equations individually. And one of the common factors that guides these problems is you have one large structure that is broken down into multiple small structures, or the other way around. You have multiple small structures, they are melted and joined to form one large structure. The total volume in either case is going to remain the same. The principle behind such problems is total volume is constant. First, break the problem down into individual parts, set up the equations accordingly, and then cancel out the common factors, introduce numbers as late as possible. This will help you solve problems faster in an uncomplicated way, and it saves a lot of time and energy as well. Thank you.